Welcome everyone to Before Engineering channel. Today in this video, I'm going to help you to understand the basics of integration. Mainly, try to explain what is an integration, what are the application of integration. As many of you know, integration help us to find the area, volume, velocity, acceleration, etc, etc, etc. Here the purpose of this video is to understand what we do during the integration process. Now we can come to the point of what is integration. Integration can be used to find area, volume, center point and many more applications. We can start integration, find area under a curve of a function f of x. That is, it is like this one. This is the curve based on the function f of x, and it is lying in a plane xy plane. We want to find out the area under this curve. What we can do, we will take a small slices like this, small slices like this. The width of this slice is, suppose we can consider it is as delta x, and again there is another slice. We will put it here, again. Okay, what we will do, we will add these slices because it is a, you know that the area of this slice is with length into width. We will add these slices, we will get an approximate value of area under this curve, but it is not accurate because there is a gap in between all these slices. Then it will not be accurate. Okay, then what we will do, we can say that if these slice, this is a slice, this slice, it is approaching to 0, that is, it is a minute value. That width of this slice is, the width of the slice is very less. It is not able to see in our naked eye also. Then we can write this slice with this delta in dx instead of delta x because it is very small. And but there is a problem. If we are taking this dx, this is a very small value, then it will become around 1,100 or lakhs of slice will be coming under this curve. Adding these all slice, it is very difficult process for finding out the area under the curve. So what we'll do, we want to go for a shortcut. What we do, this, there is a simple function. What we will do, this slice, this dx slice will move along the x-axis, based on the function f of x. That means this slice, simply we are moving this one, but based on the function f of x. Then we can say area is equal to, area under this curve is equal to integral of from 0 to x, where is x might be some 5 or 10, 6, 7, 8, 9, whatever the value, 0 to x, and it's a moving slice dx, then based on the function fx. What we are saying, there is a shortcut. There is nothing in this shortcut. The shortcut name is integration. For finding out the area under the curve during the integration is an easy process. If it is the curve, it is not defined curve. If it is undefined curve, we will be split at the curve. For defined curve, then we will do adding some integration and we will find out the area under the curve. Now we can check how we can find the volume by integration. Now let us consider a Cartesian coordinate system. There is axis x, y and z. Now what we are doing, we are considering three minute small points located origin of the Cartesian coordinate system, that is such as dx, dy and dz, that is dx, dy, dz. Now what we will do, we are going to move this dx along the x direction, maybe say around 5 meter. We are moving this dx along the x direction, then what we can write length of this dx is if the dx is moving from 0 to 5, what will get the length of this line, that is we will get 5. Am I right? Okay, this is we will get 5. Then length of this path is equal to, we can write length of this path is equal to integral 0 to x. Initially we are not putting 0 to x, where from it will start from 0 and it will be n some value of x. What is moving, dx is moving along the x-axis, that is equal to, here it is equal to 0 to 5 integral 0 to 5 dx. Then we can write length of this path is equal to what we are previous slide, we see that one, it will move 0 to x dx. Now what we are going to do, we will move this 0 to x or 0 to 5, this 0 to x dx line, move along the y-axis, y direction, move along the, that is 0 to x dx. This is 0 to x dx or 0 to 5 dx or 5. If we are moving along the y direction, then what we will get, we will get an area of the xy plane. If it's there is some value is there, then area will be multiple of x into y. Then we can write area of xy plane is equal to integral of 0 to y, integral of 0 to y. Then what we move, we are move the value of x, that value of x is 0 to x dx into dy, that is equal to 0 to 6 along the y-axis, 0 to 5 along the x-axis. Now we already find out the area of this plane. Area of this plane is integral 0 to y, integral 0 to x dx dy. Now we move this plane along the z direction. Say we can say it is a 3 meter. Then what we can write? We can write volume of this figure. We can say integral what we want, we move this plane along z direction, that is from 0 to z. What we done, this plane already we find out in the previous area equation in xy plane, that we will put here area of xy plane, that is equal to, the plane is moving 0 to z direction, the plane value is 0 to y, integral 0 to y, 0 to x dx dy, that is equal to, we can say it is in the triple integral of 0 to x y z dx dy dz, integral 0 to triple integral of 0 to 563 dx dy and dz. Once we are adding this solving this integration, we will get an answer 5 into 6 into 3, that is equal to 90 meter cube. If you like this video, please like and subscribe the channel, and thank you.